Hello and welcome to my Level 2 Further Maths AQA Predicted Paper 1 for this summer. Before we begin, some general information. Firstly, I highly recommend that you download and try doing this paper before watching the video. You can find a link to that paper in the description. Secondly, this paper perfectly covers the advanced topic list released by the exam board back in February. There is, however, no guarantee that questions will be asked exactly in this way, but this paper is surely excellent practice for your summer exams. Finally, due to the nature of the questions you're being assessed on in this paper, some of the questions may have alternative approaches. I'm going to show you one approach in this video, but as long as you get to the right answer, other approaches may be valid. For this question we have 2 points, A and B, and we need to find the length of the line joining them. To do this, I will draw this right-angled triangle. The difference in the y coordinates is 3 take negative 2, which is 5, and the difference in the x coordinates is 3 take negative 5, which is 8. We can now do Pythagoras. So 8 squared add 5 squared gives you 89, which means the hypotenuse is the square root of 89, so that's the answer. For this question we have a formula and we need to make m the subject. First of all, times both sides by p to the power 4. On the left you'll then get 9p to the 5, and on the right the p to the 4 will cancel, so it's just m to the 3 plus 3. The next step is to take away 3 from both sides. So on the left we've now got 9p to the 5 take 3, and on the right the 3's cancel, so it's m cubed. Now we cube root both sides. Cube rooting the left is just the cube root of the left, and cube rooting m cubed is just m. We've now made m the subject, so our answer is m equals the cube root of 9p to the 5 take away 3. For this question we have t plus 10, which is being increased by 20%. To increase by 20%, you times by 1.2, so we'll have 1.2 lots of t plus 10, and we're told the answer to this is t plus 19, so this equals t plus 19. If we expand the brackets, we get 1.2t plus 12, and on the right hand side it's still the same. Now take away t from both sides. On the left you'll get 0.2t plus 12, and on the right the t's cancel, so you're left with 19. Now take away 12 from both sides. The 12 on the left cancels, so it's just 0.2t, and on the right 19 take 12 is 7. Now times both sides by 5, or divide by 0.2 if you wish, and you'll get the answer t equals 35. For this question we have a triple bracket to expand. I'm going to expand the first two brackets. So we'll do 3x times x to get 3x squared, 3x times negative 2 to get negative 6x, negative 4 times x is negative 4x, and negative 4 times negative 2 is positive 8. You can simplify these two terms here, so we'll end up with 3x squared, take away 10x plus 8. We then times this by the final bracket. To do this, we'll times each of the terms in the first bracket by each of the terms in the second bracket. I'll start by doing 3x squared times by both terms in the second bracket. So 3x squared times 2x is 6x cubed, and then 3x squared times 3 is plus 9x squared. I'll now times negative 10x by both terms in the second bracket. So negative 10x times 2x is negative 20x squared, and negative 10x times 3 is negative 30x. Finally, I'll do 8 times both of those two terms, so 8 times 2x is plus 16x, and 8 times 3 is plus 24. We can now simplify, so we have 6x cubed. If we simplify the x squareds, we get 9x squared take 20x squared, which is negative 11x squared, and then the x's, we have negative 30x add 16x, which is negative 14x, and finally plus 24. For this question we can expand the brackets first, so the first bracket would give you 6ax take away 9, and the second bracket would be plus ax plus 4a. This is identically equal to 35x plus b. We can simplify a little bit on the left hand side. 6ax plus ax is going to be 7ax, and then we have negative 9 plus 4a is identically equal to 35x plus b. Now if we equate the coefficients, on the left we have 7ax, and on the right 35x. This tells us that 7a must equal 35, in which case a equals 5. If we look at the constant terms, we have negative 9 plus 4a, which must equal b. So negative 9 plus 4a equals b, but of course we know a was 5, in which case 4a is equal to 20. So now all we need to do is negative 9 plus 20, which gives you b as 11. So A is 5 and B is 11. In this question we have a sequence with an nth term, and we need to find out when it equals 4/5. To do this, set the nth term equal to 4/5. To solve this equation we can cross multiply, so on the left we get 5 lots of 3n plus 1, and on the right 4 lots of 4n minus 2. You can expand these brackets, which will get you 15n plus 5 and 16n minus 8. We can now solve this equation by taking 15n from both sides. On the left the 15n's will cancel, leaving you with 5, and on the right 16n take 15n is just n, so it's n take away 8. Finally add 8 to both sides. On the left you'll get 13, and on the right the 8's will cancel, so you got n. So n equals 13. For part B we need to find the limiting value as n tends towards infinity. So we have this nth term here. As n gets very large, the plus 1 and the negative 2 here become insignificant. So we tend towards 3n over 4n. If you now cancel the n's, you can see that the limit will be 3 over 4. To rationalise this fraction, we'll times the top and the bottom by 3 plus root 5. We'll start by multiplying the top, so 5 times 3 is 15, then 5 times root 5 is plus 5 root 5, then root 5 times 3 is plus 3 root 5, and finally root 5 times root 5 just gives you 5. We'll do a similar approach on the bottom. 3 times 3 is 9, 3 times root 5 is plus 3 root 5, negative root 5 times 3 is negative 3 root 5, and negative root 5 times positive root 5 is negative 5. We can now simplify. So on the top you've got 15 add 5, which gives you 20, and then 5 root 5 add 3 root 5 gives you 8 root 5. On the bottom 9 take 5, that's 4, and these two terms here cancel out. We're almost there. 20 divided by 4 gives you 5, and then 8 root 5 divided by 4 is 2 root 5. For this question we need to find the coefficient of x cubed in this expansion. This bracket is to the power 5, which means if we're going to get x cubed, we also need to take 2a twice, so we'll start with 2a squared times x cubed. We then need to consider all of the possible combinations of ways of selecting these. Since the bracket's to the power 5, and we're selecting 2a twice, we could do 5 choose 2. You could also do 5 choose 3, they'll get you the same number. If you look at Pascal's triangle, you can see 5 choose 2 is equal to 10, so we'll replace it with 10. So we have 10 times 2a all squared, which is equal to 4a squared, times x cubed, and if we times this we'll get 40a squared x cubed. In the question we're told the coefficient of x cubed is 360, so 40a squared must equal 360. If you divide both sides by 40, you'll get a squared equals 9, then if you square root both sides, you'll get the answers, which are 3 and negative 3. For this question, we can find the inverse function first. So if f of x equals the cube root of 2x, we can say y equals cube root of 2x. If we then rearrange this to get x the subject, start by cubing both sides. On the left you'll get y cubed, and on the right the cube root will disappear, so it's just 2x. Then divide both sides by 2, and you get y cubed over 2 equals x. If you now switch x's and y's round, then you get x cubed over 2 equals y. So inverse f of x equals x cubed over 2. We've been asked to find inverse f of negative 4, so we'll substitute in negative 4. Negative 4 cubed is negative 64, so negative 64 over 2 is negative 32. For this question we're solving g of x is less than h of x. So we'll write down what g of x is, that's 2x squared plus 3x take away 19, and that must be less than h of x, which is x squared minus 9. To solve this we'll get rid of the terms on the right, so we'll take away x squared and add 9 to both sides. On the right we'll get 0, but on the left hand side we'll end up with x squared plus 3x take away 10. This is a quadratic that factorises. It would be x plus 5, x take 2, and this is still less than 0, and that gives us two critical values, which are x equals negative 5 and x equals 2. This tells us if we draw the graph of this quadratic, it would cross the x-axis at negative 5 and 2, like this. Our inequality says we want this to be less than 0, so we're looking for this bottom portion of the graph here, since that's less than 0. This corresponds to x values that are in between -5 and 2. So our solution is x is in between -5 and 2. For the first part of this question, you simply need to know the value of cos 30. You should know this as an exact value as √3/2. For the second part, we need to draw on a line at -k. The line already drawn is at +k, so the one at -k would be here. We can now see the two solutions where this red line crosses the cos graph. They're here and here. We just need to work out the corresponding x values for them. We can do this using the symmetry of the graph. If you look at the x values for when cos x equals +k, you can see this distance here is 60, since it goes from 30 to 90. That means this distance will also be 60, so if we do 90 add 60 we get 150. That's one of our solutions. In a similar fashion, this distance here is 60, so this one's 60. In this case we do 270 take away 60, and we get 210. So our solutions are at 150 and 210 degrees. We need to draw this graph in 3 sections. First of all, we have x values from 0 to 5, where it's equal to x brackets x minus 4. Possibly the safest way to do this is just substitute in x values. So let's start with 0. If you substitute in 0, you get 0, so there's a cross at the origin. If you substitute in 1, you get -3, so there's a cross here. If you substitute 2, you get -4, so there's one here. 3 gives you -3, and 4 gives you 0, and finally 5 gives you 5. So we get a nice smooth quadratic curve here. For the next part, it's equal to 10 minus x from 5 to 8. You should recognise this is going to be a straight line, so we'll just do the endpoints. If you do 5, you get 10 take 5, which is 5, which makes sense because we've already plotted the point 5,5. If you use 8, you'll get 10 take away 8, which is 2, so there's also a point at 8 too, and we can connect these with a straight line. For the final part, it's equal to 2, between 8 and 10, so there's just a horizontal line at 2, between 8 and 10. To start this question, we're going to write out the first differences. So to get from 0 to p, you add p. To get from p to 16, you do 16 take away p. And to get from 16 to 33, you add 17. Since this is a quadratic sequence, we'll also do the second differences. So the difference between p and 16 take away p is 16 take away 2p. And to get from 16 take away p to 17, this one can be a bit tricky, so I'll write it out. You've got 17, and then you'll take away 16 take away p, which is 17 take away 16 but plus p, which is 1 plus p. These are the second differences. Now since this is a quadratic sequence, the second difference must be constant, so 16 take away 2p must be equal to 1 plus p. We can solve this equation. We'll start by adding 2p to both sides. On the left hand side the 2p's will cancel, so we've got 16, and on the right hand side it's 1 plus 3p. Then take away 1 from both sides. On the left you get 15, and on the right the 1's cancel, so it's 3p. Then divide both sides by 3, and you'll get the answer p equals 5, which is the answer to the question. Now we need to find the nth term of the sequence, so we'll change p for 5 since we found that out in part A. The first differences are as follows, 5, 11 and 17, and the second differences are both 6. If you halve 6 you get 3, so this must be a 3n squared sequence. So if we write the sequence out, and then underneath this write 3n squared, and work out those numbers, if you subtract both of these you'll get the linear part, so we end up with this sequence, and to find the nth term of this isn't too hard. The difference is take away 4, so it's a -4n sequence, but we're starting at -3 not -4, so you need to add 1. If you combine the 3n squared and -4n plus 1, you'll get the nth term, 3n squared take away 4n plus 1. You should recognise that matrix M is just 3 times the identity matrix. This means the transformation is just an enlargement with scale factor 3 sent at the origin. In this question we have transformation A, which is rotation through 90 degrees about the origin. This has the following matrix. We also have transformation B, which is a reflection in the line y equals x, which has this matrix. We then have transformation C, which is transformation A followed by transformation B. So C must be equal to BA. It's important that you multiply them in this order because transformation A is done first and transformation B is done second. You cannot do AB. So we need to multiply matrix B by matrix A. So we'll do 0 times 0, add 1 times negative 1, which is negative 1. 0 times 1, add 1 times 0, which is 0. 1 times 0, add 0 times negative 1, which is 0. And finally 1 times 1, add 0 times 0, which is 1. In the question we are asked to show that this is equivalent to a single reflection, and it is. Hopefully you recognise this as a reflection in the y-axis. The first thing to do on this question is rewrite the 6 over x as 6x to the power negative 1. We can now differentiate, so dy by dx equals, we do 3 times 8a, which is 24a, and then bring the power down from x cubed to x squared. We then do 6 times negative 1, which is negative 6, and then reduce the power from x to the power negative 1 to x to the power negative 2. In the question we're told that y has a minimum when x equals 0.5. If we have a minimum, then dy by dx must be equal to 0, so we can write this equals to 0. It might be sensible at this point to rewrite the second part of this back in its fraction form, so 6 over x squared. We were told that this minimum happens when x equals 0.5, so we can substitute 0.5 in for x. 0.5 is just a half, and half squared is a quarter, so we can replace those 0.5 squareds with 0.25s, like this. So we have 24a times 0.25, a quarter of 24 is 6, so that's 6a, and then we have 6 divided by a quarter. Dividing by a quarter is the same as timesing by 4, so we've got negative 24, equals 0. We can solve this equation really easily. Take away 24 from both sides and you'll get 6a equals 24, and then divide both sides by 6 and you'll get a equals 4, which is the answer to the question. To start this question, we're going to find the length of line AC. We'll do this using Pythagoras since it's a right-angled triangle. So AC equals the square root of 12 squared take 10 squared. 12 squared is 144 and 10 squared is 100, so this is equal to square root 44. We can simplify this a little bit. Since 44 is 4 times 11, this is square root 4 times square root 11, and square root 4 is equal to 2, so AC is 2 root 11. We can now go ahead and find DC using the sine rule. So DC divided by sine 30 is equal to our new side that we just found, 2 root 11, over sine x. You can times both sides by sine 30, so DC would equal to 2 root 11 times sine 30 divided by sine x. Now sine 30 is equal to 1/2, so the sine 30 will cancel out the 2. So what we're left with is root 11 over sine x. In the question though, we're told that sine x equals 2/3, so we can replace the sine x with 2/3. So we need to do root 11 divided by 2/3, which is the same as root 11 times 3 over 2, which gets you the answer for DC, 3 root 11 over 2. There are a number of different ways of proving this. I'm just going to show you one of them. So I would label onto the diagram, this angle here is x, and this angle here is 2x. So I could state that DAC equals x and ACD equals 2x. But you should always explain each of your steps. So I would say that this is due to the alternate segment theorem. I notice in the question that AB and CD are parallel. So if you draw on this shape here, you can see that due to alternate angles, this angle here is also 2x. So I would state BAC equals 2x, and the reason would be as it's an alternate angle with angle ACD. Now I would look at these two angles here. They are opposite angles in a cyclic quadrilateral, so must add up to 180. The left angle is 2x add x, and the right angle is 2x add w. So if I add all of this together, it must make 180. And the reason again is because they are opposite angles in a cyclic quadrilateral. From here I can simplify. If I add 2x, add x, add 2x, I get 5x. So it's 5x plus w equals 180. All you do now is take 5x from both sides and you'll get w on the left, and on the right 180 take 5x, which is what we needed to prove. In this question we have the square root of 3 to the 9 plus 3 to the 6. I would write this out again but factorise inside the square root by taking out 3 to the 6. Inside your bracket you'd then get 3 cubed and plus 1. If we look at 3 cubed, we know what that is. That's 27, so write it out again, but change the 3 cubed to 27. And then 27 add 1 is just 28. So now it looks like this. You can now use your surd multiplication rule to write this as the square root of 3 to the 6 times the square root of 28. To do the square root of 3 to the 6, you just halve the power, so that's 3 cubed, and square root 28 can be written as square root 4 times square root 7. 3 cubed is 27, so we'll change that, and square root 4 is just 2. So we have 27 times 2 times root 7. 27 times 2 is 54, so this is 54 root 7, and that's now in the form we were asked for. I'm going to start this question by drawing on the line from C to P. If you look at the coordinates of these, you can see that the line has length 5, since it goes from 0 up to 5. So CP equals 5, and it's the radius of the circle. I'll now draw on the line C to Q. This is also the radius of the circle, so CQ must also have length 5. I'm now going to draw on a right angled triangle between C and Q and have a look at this in more detail. So we have this triangle, where C is the bottom point at 10, 5 and Q is the top point at 13, m. We know the length of the blue line is 5 since it's the radius. You can also work out the base of this triangle. Since C has an x-coordinate of 10 and Q has an x-coordinate of 13, it must be 3. This is a right angled triangle, and hopefully you spot a Pythagorean triple here. The height is 4 and it's a 3, 4, 5 triangle. We can use this information to work out the value of m. C has a y-coordinate of 5, and Q is 4 higher than this, so we do 5 add 4, and you find out that m is actually 9. There are some other ways to find this out. You may have, for instance, used the equation of a circle. For the next part of this question, we need to find the equation of this purple line. To do that, you need the gradient of the line and also a point on the line. We've already got a point on the line, Q, which is at 13, 9, so we need the gradient. We can get the gradient of the line CQ. Looking at our diagram here, we do the change in y over change in x, so it's 4 over 3. The gradient of the purple line will be the negative reciprocal of this, since the lines are perpendicular. So that would be the gradient of QR, which is negative 3 over 4. Now we know the gradient and a point on the line, we can substitute those into the general equation of a line. So the y-coordinate will be 9, the x-coordinate will be 13, and the gradient will be negative 3/4. So we'll say y, which is 9, equals negative 3 over 4x, which is 13, plus c. If you leave 9 on the left but on the right, do negative 3/4 times 13, you get negative 39 over 4 plus c. If we now change the 9 so it's over 4 as well, it will be 36 over 4. And then we add 39 over 4 to both sides and you'll get c equals 75 over 4. So the equation of this purple line is y equals negative 3/4 x plus 75 over 4. We can now find out the coordinates of r down here. R is on the x-axis, so the y-coordinate is 0. So if we write out the equation of this line but change y for 0, we can find x. So 0 equals negative 3/4 x plus 75 over 4. If you add 3/4 x to both sides, you get 3/4 x equals 75 over 4, which leads you to 3x equals 75 and x equals 25. So the coordinates of r are 25, 0. In the question we were told the ratio OP to PR is 2 to k. You can see the distance from O to P is 10, and since the coordinate of r is 25, the distance from P to R is 15. So the ratio OP to PR is equal to 10 to 15, which if we simplify by dividing by 5 gives you 2 to 3. So the value of k is 3. In this question we have an expression, and the first thing to do is change tan x for sin x over cos x. You can see now the cos x's will cancel. So we're left with 8 take away 3 sin x times sin x, which is 8 take away 3 sin squared x. You should also know a trig identity sin squared x plus cos squared x equals 1, so we can replace the sin squared x with 1 minus cos squared x like this. If you expand this bracket, then we end up with 8 take away 3 plus 3 cos squared x, and if you simplify, 8 take 3 is 5, so it's 5 plus 3 cos squared x, which is the same as 3 cos squared x plus 5 and matches the form we were asked for. In this question we're told that y equals 2x plus 1. What we're going to do is rewrite the first equation but substitute y for 2x plus 1. So we have 3 Then it's y squared, but we know y is 2x plus 1, so it's 2x plus 1 squared. Take away xy, so it's take away x lots of 2x plus 1. And then take away 4x squared, take away 13 equals 0. So we have 3. Then if you expand this bracket, you get 4x squared plus 4x plus 1. And then negative x times 2x is negative 2x squared, and negative x times 1 is negative x, and the rest of the terms are the same. We can then expand this bracket, so 3 times 4x squared is 12x squared, 3 times 4x is plus 12x, and 3 times 1 is plus 3, and then the rest of the terms. We now need to simplify, so we have 12x squared, take 2x squared, take 4x squared, which is 6x squared. If you then look at the x's, you've got 12x take x, which is 11x, and then the constant terms, we've got 3 take 13, which is negative 10, and this equals 0. Now you can factorise this to get 3x take away 2, and 2x plus 5 equals 0. Each of these brackets has a solution. The first one is x equals 2/3, and the second one x equals negative 5 over 2. So we now have two solutions for x. We need to get the corresponding y values. You can use either of the equations, but I'd strongly recommend using the second one, y equals 2x plus 1. So y equals 2 lots of 2/3 plus 1, which gets you 7 over 3, and then y equals 2 lots of negative 5 over 2 plus 1, which gets you y equals negative 4. So we have two solutions, x equals 2/3 with y equals 7 over 3, and x equals negative 5 over 2 with y equals negative 4. Thank you for watching this video, I hope you found it useful. I've included the grade boundaries from the most recent exam so you can get an idea about how well you may have done. Check out what I think you should watch next and subscribe so you don't miss out on future videos.